It is the most powerful and terrifying engine on our planet. A self-sustaining heat engine the size of a country. Born from nothing more than a whisper of warm ocean air. For centuries, we have stood in its path, our fates tied to the whims of its track and its fury. For most of human history, our only defense was a prayer. Then, our shield became the forecast. But that forecast has always been a battle, a brutal fight between brilliant human minds and our most powerful supercomputers. But now, a new force has entered the battlefield, a technological storm of its own. It doesn't use the laws of physics, at least not the way we programmed it to. It doesn't think like a human, and yet it's already predicting these storms with an accuracy that is rewriting everything we thought was possible. This is the silent revolution of artificial intelligence in human forecasting. Today, we're going beyond the headlines to show you exactly how these new models are outperforming the systems we've relied on for decades. Real world cases, moments where AI saw what humans missed. But stay with us, because soon we're pulling back the curtain on the deep, almost terrifying flaw in these systems, and why it means the human forecaster might be more important than ever. To truly understand this revolution, we first need to appreciate the old guard. For the last half century, forecasting has been a war of brute computational force. Massive, physics-based numerical weather models, like the American GFS and European ECMWF, and specialized hurricane models like the HAFS. Think of it like this. We're trying to build a hurricane from scratch, atom by atom, using pure mathematics. These models divide the entire global atmosphere into millions of tiny grid boxes. Each second, supercomputers calculate temperature, pressure, humidity, wind, and how all of it violently interacts with everything around it. Step by step, minute by agonizing minute, for days into the future. It's magnificent computation, but it's slow. It takes hours to run on machines that fill entire buildings. And even then, it is not always right. These models can struggle with complex steering environments, missing the exact birth of a storm, and most dangerously, failing to predict rapid intensification. Now, enter the new contender. Born not in a meteorology lab, but in the server farms of big tech. Artificial intelligence. Systems with names like Google DeepMind's GraphCast, NVIDIA's ForecastNet, Huawei's Pangu-Weather. These models work differently. They don't follow physics. They learn physics. It's like a chess grandmaster who studied every match ever played. They don't check every possible move. They feel the right one. AI does that for the atmosphere. It studies decades of global weather, and in that ocean of data, it finds invisible patterns. The result? It can generate a highly accurate 10-day forecast in less than 1 minute. What takes a national supercomputer the better part of a morning? AI does that before your toast is ready. But the question is it better? The 2023 hurricane season gave us an answer, and that answer was shocking. The moment meteorologists sat up straight was Hurricane Otis. At first, Otis was just a mid-range tropical storm. Most traditional models saw it as a manageable threat. Tropical storm, maybe a weak Category 1. But the AI models, they saw a ghost in the data. A rare combination of a tiny storm core and an exceptionally deep pocket of warm water. They raised the alarm that Otis might explode into a major hurricane with Acapulco directly in its path. They were horrifyingly correct. Otis slammed into Acapulco as a monster Category 5 hurricane. Even though the storm became even stronger than the AI forecasted, the fact that it saw the potential was a breakthrough. The AI's foresight was the difference between a day of preparation and a city's ruin. So that's it, right? Game's over, the machines win. Not so fast. Here's where the story takes a darker turn. First, there's the black box problem. AI doesn't explain its reasoning, but it's a brilliant student who aces every test, but can't show the work. You trust the answer, but you don't know it's right. And then there's the deeper flaw, the gray swan. AI is a prisoner of its past. It recognizes patterns it's seen before, but what happens when a storm does something entirely new? With climate change rewriting the rules, these gray swan storms are coming. A physics model might simulate the unimaginable, but an AI might search for a pattern that doesn't exist. Or worse, create a false one. And that brings us to the human. This isn't the end of forecasters, it's the beginning of something bigger. Humans and AI together, forecaster in the loop. The meteorologist as master interpreter, risk psychologist, and vital communicator. They'll sanity check the AI, apply local knowledge, spot the weirdness a machine might miss. Most importantly, they'll stand in front of the public with wisdom born from years of storms and say what the machines can't. Here's what this means for you. Now, I want to hear from you. Would you trust a forecast from a black box AI without a human expert to explain it? Let me know your thoughts in the comments below. If you found this deep dive valuable, hit that like button, subscribe to the Hurricane Watch team, and tap the bell icon so you never miss an update. Stay safe, stay informed, and we'll see you next time. Peace out.